Hi, welcome back to Geek Toolkit. I'm Joe Farrow. What I wanted to talk about today is a tool called Tinkercad. Tinkercad is a 3D modeling tool. This means that you can take an idea from your head, go into Tinkercad, use this tool, and create it visually in 3D. You can then take that output of that tool, put it into a 3D printer, and end up with the thing that you had a thought in your head like this, and hold it in your hand. And I think that's just really powerful. It's really what got me fired up about 3D printing. It was really cool to download other people's models and print them, but when I made my own, I really felt like I was progressing. Now, the thing about learning Tinkercad is we're learning design, and design is iterative. So even the design I'm going to show you in this video is a second version of what I created. The actual one that I put up on Thingiverse, which is where I'm storing it, is actually a version 3. That's almost as an important lesson as anything in learning in Tinkercad, is that your first version is not going to be perfect. Now, what we're building today is this. And what it is, it's a joystick holder. It mounts against the wall. It's got a 15-degree tilt. It's got two little knobs here, and it's got a logo. It's very simple. But the way it works is I've got a joystick, and the joystick will slide forward and give me a little bit of an affordance on the back here. And the idea is that I can wrap the cable here. So it's both a joystick holder and a cable wrap. And I'll show you at the end of the video what this looks like up on the wall. For now, the parts of this video are going to be the Tinkercad tutorial, then I'll show the 3D print and the final product. Thanks for watching, and let's get started. This is the Tinkercad UI. It's tinkercad.com. I've modeled a quick joystick that is the same dimensions as the one that I want to build a holder for. This is the one I have is actually a Commodore 64 joystick, and it's 116 millimeters square about. And I modeled it so that when we build the holder over here, we can kind of move it over and get a visual kind of a sense. Also, it gives me an easy way to show you guys the measuring without having to do edit cuts back and forth of measuring different parts of the joystick. So really, the only thing I need is to know that this is 1/16 square though, and I have everything I need to know. What I'm doing to move around like this is right-clicking on the mouse pad or the mouse on your mouse, and then drag around. This gives you a typical, I believe it's just called a ball rotate. For zoom, you want to use the plus and minus. It's a very simple program to get around in. There's not a lot going on here. Over here is your shapes, your drop down. You can go to from basic shapes to more complex. You see characters, connectors. Connectors is super useful for 3D printing. Circuits. Tinkercad's kind of an odd tool. It can do 3D printing. It can also do Arduino circuits. We're going to just stick with basic shapes. Drag it over. Just left click, click and drag. It places it over here, and it places it flat on the base here. You can think of this base as where your 3D printer is going to print on. You can click these squares here to resize. This one will go up and down. This one will go left and right. Because of that, when you click on this left one, it shows you the width here. If you click on that width and type it in, then you've resized it. This one here is for height. This is all in millimeters. You can edit the grid to change it to inches. And if I'll click the arrows, I can move stuff around. Right now it's being moved as a snap of 1.0 millimeter. I can move that to 0.1 millimeter. All right, so what I'm going to do is start modeling this out. And as I hit things that I haven't discussed already, then I'll explain them. Right now, we want to make a 1/16 wide square. Said 1/16 wide square, which doesn't make any sense, because if you make a 1/16 square, it'd be wide and height width and height 1/16. And I actually want to make it more than 1/16 here. I'm going to make it 125. The reason I'm doing that is the way I'm envisioning this is when the joystick's placed on top of here, we're going to put a little bump up front here to hold the joystick. We're going to have a bump on the back here
that will go up against the wall with a keyhole to screw into. And I want to leave a little bit of room for a cable to go through. So the cable should come off the back of the joystick and wrap around this when it mounts on the wall. So we can see when we put that on there, it didn't give us a ton of space. So I'm actually going to take it up to 130. Now what I want next is I want to put a box on the front of this so that the joystick doesn't fall off the front. You can imagine this slanting downward when it's on there. So let's make it 1/16 wide, and we definitely don't need it to be that thick. So let's go with our 2.5 millimeters. I'm liking the idea of things being about 2.5 millimeters for being thin enough to not get in the way and waste filament, but being thick enough to have some strength to them. Okay, so that's lined up. Basically, I just clicked on it. When you click, you select it, and then you can drag around to move it. I like where that's at. Control C, Control V will make another one when it's selected. If I hold Shift and drag, then it will lock it to the axes I'm dragging on. I need to rotate this now. When it's selected, these arrows up here are a rotation degree. Again, you can click and drag, or you can just type it in. And then I'm going to move it back slightly. Okay. The next thing I want to do is make a keyhole so I can put a screw through the back of this into the wall, and then the joystick would just sit on this here. Kind of just sit like that. And again, this is so I can visualize this. The joystick will slide forward, hopefully, onto here, and the cable will wrap back here. And you can see this is still not aligned. No big deal. I'm going to show you a trick to align everything. What I'm going to do is hold down Shift and click on things to select multiple. I clicked on all three shapes. And you can see shapes 3 here. That shows that I have 3 of them selected. And if I click this here, this is the Align tool. All of these black dots are different ways to align these 3 shapes. If I click on this, it'll preview. You'll see the orange up here. It's previewing what that would look like. So this aligns them on the center. This would align them on height. This would bring the base up to the top. It would basically align it almost like a bed. I'm going to click here. And now I can see that my corners are perfectly aligned. Everything's aligned here and here. Okay, so we've drugged things over. We've moved them. We've rotated them. Let's make some holes. The way Tinkercad works to create shapes is you take basic shapes like these and you either combine them or you make holes in them. Okay, no big deal. We'll change this to 7 here. 7 here. We'll make a happy little circle. Control C, Control V. Now I've got another circle, and it is also 7. And what I'm going to do is I'm going to elongate this one a little bit, and I'm going to make it 5 by 5. Okay. Now I'm going to bring it back a little bit, and let's zoom in so we can see what we're doing here. I'm kind of taking a little flyby as I get worked around to where I need to be. Here we go. Okay, so these are both selected. I'm going to do an alignment. By the way, when you zoom in and out, don't use the mouse wheel. What will happen is you'll end up zooming your browser in and out since it's a browser app, and that will cause it to become very buggy. Okay, so these are actually aligned. If you see it gray, the gray means they're already aligned. So that means that these are centered. Now remember, to create shapes, we just combine them. The combine is up here. When I click that, I should have my keyhole shape. I need to rotate it. So we're going to take the keyhole from the side here, and I know I want to rotate it 90 degrees. I'm going to mouse over the arrows, click up here, 90 degrees. There we go, there's my keyhole. Wait, did I do it upside down? I did do it upside down. Okay, let's rotate it 180. Yes, that's how keyholes work. Okay. So now, again, Control C, Control V, hold down Shift, click and drag, and I get my second keyhole over here. There we go. And I'm going to combine these objects together. So it says shapes 5. That's 2 keyholes, the back portion, the bottom portion, and the front, which are all different shapes. When I click this combine button, it'll become one shape. You see the keyholes are in the back here. The bottom's there, the front's there. And now if I move this, it moves as one shape. If I adjust properties, if I want to change colors, I click on solid and change colors, it'll change colors. I'm planning on printing on black PLA, so I'm going to make it black for now. Okay, so now let's talk about optimizing this for a 3D printer. I could definitely print this as is, but I would be wasting a ton of filament here. Reason being is, when this is sitting on top of this, it doesn't need all that space to support it. The controller's not that heavy. So what you'll see a lot of people do with the 3D print is they'll put a pattern in here or they'll cut things out. Same with this front. We don't need the entire front here. We may not need it that high. We definitely don't need it that wide. If the controller's sitting there and it pulls forward, it only needs maybe a bit on either of the edges here. And finally, the back here, once these keyholes are screwed in, the rest of this flat surface is doing nothing structurally for the amount of weight we're dealing with. So we've got a number of areas that we can work on. And it's also an opportunity to design it up a bit. First thing I'm going to do is make a hole here in the front. I'm going to click on this box and basically just stretch it across here. And then I'll select both of these, align, and I'll center it. Now that's gray. It's perfectly centered. So when I combine these two together, two shapes are selected, and we do a combine, it'll cut that front out. Now you can see it cut into my piece a little bit, and I didn't necessarily want that. I just kind of wanted the front cut out here. So I'm going to hit Control Z to go back one. I'm going to select the piece, and I want to lift this up in Z-axis. Everything in Tinkercad goes on the ground by default, and there's a little arrow here. Here, let's do this. We're going to take the shape and make it a different color just so you can see this arrow better. There we go. And this arrow here, when I do that, it moves up. Now if I select them, I combine them. Oh, I took a little bit out of the front here. Move it up a little bit more. There we go. That should be plenty. Okay. We can do the same with the back. And you start seeing a pattern here. Basically, it's create a shape, place it, combine them, and you're pretty much golden. I'll do an align, I'll center it, I'll click on it, raise it up a little bit. Here we go. Go up a bit, highlight, combine, Okay, so now we've reduced the amount of filament that we're going to use on the 3D print. All right, so I've got my pixel art loaded. It's colored, which is going to be helpful in the next step. What we want to do is select it and then go path. Now I see my live preview here. Live preview is important because as you change settings here, it'll update the preview. What you're looking for, in this case, since we want to do a cutout, I want this to all be black. This looks like what I want. I'll click OK. Now when you click OK, it looks like nothing happened, but it actually put it onto the background here. So if you close that, and you see it actually put it on top of the color version. So I'm going to delete the color version out, recenter this over a little bit. I'm going to select it, File, and we're going to do Save As. I had to think about that. And you're going to have a lot of options here. Inkscape SVG seems to be the one that works best for me. I've done plain SVG in the past and not had luck with it. And I'm going to show you how to pull it into Tinkercad in a second. Now that we have that shape, we can go up to Import, choose a file. We can select the file that we just created, this C64 logo vector SVG. Open that up. And it's telling me that the workspace is limited to 1,000 millimeters cubed. It wants me to change the length and width of this. What I'm going to do is just tell it to scale 50%. It doesn't matter. It's a mathematical formula. I can rescale it pretty much losslessly anyway. Whoa, it's way big still. Okay, no problem. We'll zoom out. We'll resize it down. I just realized this resize was not, this is a resize where it can get distorted. So I'm going to Control Z to undo that. When you have an app that does that, typically holding the Shift key will force the resize to be, to maintain your aspect ratio, which is very important here. I don't want to distort the logo I'm pulling in. All right, we're almost there. Shrink it down a little bit more. And we're going to pull it over. Oop. Actually, I'm going to change the color of this to something very obvious so I can see it. The other thing I'm going to do is I'm going to make this become a hole, so it doesn't matter how tall it is. When you make a hole in something, like this is going to become a hole through the bottom of this, so it doesn't matter how tall it is. I'll make it really tall. Makes it a lot easier to manipulate. Now I want to get a top-down view. I can click up here onto the square, and that helps reset your views. It also helps you get things like a top-down view like this really easy. I'm going to use my shift drag trick again to resize this. And I think I'm just going to take it back a little bit. I don't want to get too close to the edge because I want to have the 3D print be clean. Okay, now one other trick for Tinkercad. This is a solid. Any solid shape can also become a hole. So if I click this, this becomes a hole. If I select both of these, you see two shapes, and if I combine them, boom, there you go. Now, if you're a retro enthusiast like me, this is probably a very useful thing to build. If you're not, then hopefully this tutorial showed you enough to build things that you're interested in. If you leave something down in the comments of what you'd like to see me model or what kind of things you're interested in modeling, I can tell you if Tinkercad's the appropriate tool for it, and I can probably do a demo for you. I guess there's one thing left to do over here is to give this a name. And Tinkercad will store this up in the cloud. I can log in on any web browser, sign into the account, and I would see this, basically this, it would be listed as C64 joystick.
So here's what the final project looks like. These complement my other controllers that are mounted up using other files off of Thingiverse, which I'll link in the description. I'm really happy with how they came out. The only change I did was a little bit of an affordance for the wire wrap to make it a little bit cleaner and hold a little bit better. You can see those on my Thingiverse model. It's a very simple cylinder cutout. I'm really hoping that you're enjoying these videos, and please leave any feedback on the way I taught this in the comments if I go too slow, too fast. And I'll put that into my next videos, that feedback in. The next video is going to be a bit of a project video with a Raspberry Pi, a magic mirror, and something a little bit different than I think you've seen out there. And I'm really excited for that one. So hit that subscribe button if you want to check that out, and I'll see you next video.